Hi everyone. Today I'm going to present you real-time face recognition with Microsoft services. And I'm Jernej Kavka. You can just call me JK because that's hard to pronounce. I'm Senior Software Architect at SSW, and you can follow me at Twitter, GitHub, or my blog posts. And recently I'm focusing mostly on .NET Core and Cognitive Services. And what I'm going to show you today is one of the showcases we made, just to give you a view why did we have those challenges, why did we need to go to real-time facial recognition. Then we'll go to the challenges, and then a little bit inspirational, the infrared and depth cameras, what you can do with it, and what you need to watch out when you try to use them. And before we start, on the internet there's, let's just say people don't quite know what it means detecting and recognizing. And to shed some light on it, face detection or tracking means that we can detect a face, we know where it is, we might know its emotions, gender, age, but we don't really know the face's identity. Where face recognition or identification means that for that detected face, we can put an identity on top of it. So that's very important, because if you Google, sometimes you get wrong results because people don't know that. And to begin, I want to introduce you to our SSW Sophie. It's our smart office solution. Downstairs you could see coming in. And what it does is when a user walks into the office, it detects the user, and we show some relevant content for the user. And here's a demonstration of our boss coming in, and it recognizes our boss, shows the appointment, and after that we have an actionable item, which in this case is to show them where to go. And why have we chose cognitive services? So the major reason why we did that is because it's easy to implement, and it's very scalable, and we have a unified database on the cloud. The reason why this is important, at least for us, is because we have 3 offices in Australia, and if I'm not mistaken, Adam, we have 2 offices in China. So we have to maintain faces of 5 different offices, and we want to travel between offices, and cognitive services allows us to share those faces really quickly and easily. And despite being on the cloud, it's relatively fast facial recognition, and it's available everywhere. So we can put it from the desktop machine downstairs to a mobile device or even a smartwatch. If it has a camera, we can do it. And with that, let's go to challenges we had for facial recognition. So one of the biggest challenges we had was cost. And it came because of how real-time facial recognition works. And then we had problems with keeping track of people. Are they still there? Are there any new people coming in? And the quality of camera. So environment and what kind of camera you use heavily impacts how the recognition will work. And to tackle the first challenge, we'll go to pricing. And to better understand why that would be a challenge, we need to understand the pricing. So free tier will be good enough for most of the people. If you don't need real-time facial recognition or don't need to recognize tens of thousands of faces each month, this is good enough. You have 20 transactions per minute and 50,000 transactions per month. And standard gives you 20 transactions per second and 1,000 transactions for $1, which is currently 1.373 Australian dollars checked about last week. What's important here to know is they charge you in US dollars, and then they convert it into Australian dollars. So the Australian dollars will always fluctuate. But the good news is that the last time I did a similar presentation, it was 1.8 US dollars, which is slightly cheaper now. And to better understand how this costing impacts your scenario, we'll go with a naive implementation. And we'll say for every 5 seconds, we'll take one image and try to recognize it for 24 hours. We'll not use any cache or external database, and that can cost us about 70 Australian dollars per day per camera. But it used to be $130, so at least we have slightly less cost without changing anything. But why does it cost so much? Because this is the key how to make efficient applications in general. So let's have a look what happens when we try to recognize one single person. First, we need to call an API that detects the face on the image. We get back a face ID, which then is passed to identify and returns back user ID if the user is being recognized. And then we can call getPerson, which returns the user data. So all that in total is 3 API calls and cost us 3 transactions. But what happens when you have 3 people? So surprisingly, despite having 3 people, it only costs us 1 transaction and only 1 API call. And you can recognize up to 64 faces in a single image. And when you do identify call, it also costs you only 1 API call, 1 transaction, and you can recognize up to 10 faces with 1 single call. The trick becomes is if you want to get the person's details for each individual, which you need to do for each individual person. So instead of 1 call, we have now 3 calls. And that cost us 5 transactions for 3 people, and it scales with the number of people. And to just demonstrate, because a lot of people like to see code, I'll just give you a short look at the code. In this case, I'll use Microsoft Project Oxford Face NuGet package. We have here the Face client, Face service client with the subscription key. We take an image and push it into a stream, and then we call the Face service with detect async, and we put the stream into the API call. We then call the identity method with all the detected faces. You can see we have here employees. That's the group you have. Each group can have up to 10,000 users. But if that's not enough for you, there's also a large group. We never need to use it, but it can have up to 1 million people. And each person can have up to 248 faces. So you can upload a lot of people and a lot of images. And the last part is getPerson. And we again select a group. You can have multiple groups. And we try to get the first candidate we have recognized from the previous. But you can then do also a full loop to recognize all of the people. And if anyone is aware of Vision API, the main difference between Vision API and Face API is that Face API does not support streaming or offline mode. So if you're thinking about building a model, put it into offline, that's unfortunately a Vision API, not Face API. Okay, with all that knowledge, let's see how does that translate into cost. So let's have an assumption that over 24 hours, we on average recognize 1 person. So that means we have 36 transactions per minute. And that translates into 52,000 transactions per day, which is $70 per day. And even if you don't recognize any face, that's about 17,000 transactions or $24. So here's not much that the cognitive services might be expensive. It's more like we are sending a lot of images to the cognitive services over the day. And simple cost reduction would be, the first one is not to do get person call, because you can just cache that information locally and you save at least 1/3 of all the cost. And the other one might be surprising, is to use offline face detection frameworks. So why would you use that if we have cognitive services? Well, why should we send an image to cognitive services if there is no face? This is just an extra cost we don't have to have. And the heavy lifting, the recognition, is still done on cognitive services. So there's a lot of frameworks that can deal with face detection, but they're not really a lot of face recognition frameworks that work really well in a lot of situations and a lot of ethnicities and ages. So what frameworks can you use? There are a lot of them for all the platforms, but I'll just highlight a few that I tried. So if you use Windows 10 and you develop on UWP, you have already a built-in face detection algorithm that is really good. And our SSW Sophie is using that API. There's a demo that I'll be sharing. That one is actually written in OpenCV Sharp. It's another algorithm you can use. It's basically an extension to the OpenC# library. Then we have JavaScript. You can use TensorFlow. It supports not just facial detection, but all sorts of things. You can even use a Vision API, train a model, and put it into the TensorFlow. So you're not just limited to face detection. And there's this one that is very hard to pronounce, is BRFV4. If you're interested in real-time emotion tracking, this one could be the one that would be the most interesting for you. And you have native implementation on Android and iOS, and there's heaps of implementation on Python. So with that, we have offline facial tracking with an offline framework, and we send an image only when we detect a face. But that's, strictly speaking, not really tracking. It's just like, is there a face? Okay, let's send an image. There's still a few challenges that comes with that. So one challenge is the user still present there? And are there any new faces? And the last one is unexpected cost to your environment. And this last one is interesting, at the least to say. So what happened one day is we had really good costs like 2 years ago, and we never went over $5. In fact, we were very close to having $4 as the maximum how much we get daily cost. And then this happened. I was like, whoa, what's that? And the reality, what happened is somebody put Adam Stevenson in front of the reception. And, you know, we know he's worth it, but we still want to keep the money. So what we did is we did a detect moving faces algorithm, which essentially uses the offline face detection algorithms and uses that rectangle we get for each face, and we track the movements of those rectangles. And we only send an image to cognitive services if the rectangle moves for X amount of pixels. And just to demonstrate here, this is the prototype you can download from the GitHub. You can get the URL at the end of the session. And only when I put my face in front of my my hand in front of my face, it tries to re-recognize myself. And to show you how this was implemented, we have hash-changed method, which has previous and current frame state. And frame state is nothing else as just a collection of faces, and each face has a center and a size. So it's not really that much information, and it can be used across different frameworks. And we iterate through all of the current faces. Then for that each of the new faces, we iterate through all of the old faces. We calculate the distance between current face and the old faces, and we take the shortest distance. And because we need to square root it, the shortest distance is square rooted. And if the distance is larger than the threshold, we send the image. Not that difficult, right? But this can save you a massive amount of money. And we have another algorithm that is even simpler, and I found out that actually this algorithm almost saves as much as the previous one. Do you want to see how it works? So first, I only do detection when a new face comes in, and then I send the image. And to do that, I take the number of faces of previous state, number of faces of current state, and if it's different, I send the image. Now, if you don't have time to implement the previous algorithm, this is already going to save you 95% of the cost. And I think the moral of these challenges is, if you understand what's at the cost, where the cost comes from, you can save massive amount of money. And this is not just limited to the Face API. This is for every API that is basically transaction-based. And just thinking about where the cost comes from, you can save a lot of money. And in a lot of cases, the solution is as simple as this. And if you're interested to play around with this demo, there's a GitHub link down below, but we'll move on to additional tips that might not be trivial. So crop the images before you send it to Cognitive Services. So this is not going to save you money. This is going to save you on latency, because the smaller the image, the faster the upload. And you can also take the knowledge that you can detect up to 64 faces in a single image. So why not just make a collage of faces? So instead, if you don't have to do it real time, or you can afford to wait another half a second, just string together multiple faces, and instead of paying, say, 3 transactions for 3 different faces, you can collage all the 3 and pay only 1 transaction for them. And you can identify up to 10 faces for each core. So what you can do, collect 10 face IDs and then send them to identify all the users. So all these small tips and tricks, if you really want to squeeze out the maximum out of Face API without paying much more, these are the tricks to look at. And one important thing, Face IDs, the identity method, does not require you to have Face ID from the same image. They can all be from different images. So you don't have to worry about that. And to touch on some new features in Face API, Microsoft recently introduced Docker support. So this is really awesome. How many of you like Docker? That's good, more than half. So what Microsoft gave us with Docker is a private preview, which unfortunately wasn't accepted. But I can at least give you some information what you can expect. So if you want to protect your customer data, now you can have it all in your intranet, and the images never need to exit your network. So you can have full control over your customer data. You can have lower latency by just moving your server where the call needs to happen. So if you have an Intel NUC that runs the application, you can just spin up the server right there. But does it support offline modes? Well, you need to send billing information to Azure, but I got some information that there is some limited offline support. But as I said, I wasn't able to get into the preview. I'm not quite sure how the offline mode will work. And about the cost for the containers, this is currently preview pricing. It's the same as on Azure. So we won't be able to save anything with the current preview prices, but I would expect them to at least lower it a little bit because the computation no longer happens on Azure, it happens on your own machine. And this is now covering all the software part of the challenges we had. But the biggest challenges we had is actually environmental and camera-based. And to just give you a demonstration of that, I'll give you a small clip of low-light environment with the webcam. So here you can see I'm moving my face left and right, and you can see that occasionally my face is not being detected anymore. That means that the face is blurred to such a degree that the camera no longer knows exactly what it's looking at. And if you send something like that to Cognitive Services, there's a good likelihood it's not going to be recognized. But if you use a better camera, and I swear to Connect version 2, this might be deprecated, you can see that no matter how much I move my face, it constantly keeps track of my face. And it may look like a little bit oversaturated, but it keeps just enough contrast for the Cognitive Services to work. And what is my suggestion for the cameras? Well, you should use 1080p or more. The reason for it is on the left we have the Kinect camera, and on the right we have the webcam. And you can see that on the right, the image is very smudged. And if I move like half a meter more away, the face would be unrecognizable by Cognitive Services. While on the left with Kinect, even after moving half a meter away, the face would still have enough sharpness to allow for the Cognitive Services to recognize the person. And test it on natural and artificial light. This is very, very important because if you test it in winter time at 12 p.m. and say, yeah, it works, it may not work at 4 p.m. or it may not work at 6 p.m. When summer comes, there might be too much light coming in and the camera can handle that and it might not work. So you really, really have to test it in different kind of environment, in different kind of times before you can say, yeah, it's going to work. There's another important thing is each frame needs to be very clear. If it's not very clear, you get like we had the previous example with the webcam where we were losing phase. So be sure that you take a snapshot of the images and have a look. Does the image actually look clear, or it just looks smooth because of the webcam smoothing technology? And with that, I want to show you some more experimental things we were doing, more interesting things with infrared and depth streams. And the reason why you want to use, for instance, infrared stream is because it can see at night. So can anyone guess which of those two images were taken at night? Who is for the right one? Who is for the left one? Okay, we have one for the left one. Yeah, you guessed it for the nighttime, but what happens for a really good infrared camera is when you're recording and you switch the light switch, you won't even notice when it's dark and when it's not. It just ignores the light all through together. So if you have problems related to light, is it sunlight, is it the current lightning, or other kind of light-related issues, you may consider using infrared camera. And the other really, really cool feature is it cannot see projections or screens. So you might have seen some people when they saw a facial recognition camera and they went to the phone, take a picture of a person, then try to log in as that person with the phone. Well, it wouldn't work with infrared because it wouldn't even see what's on the screen. And the other thing that we have is depth stream. So depth stream allows us to see the world in 3D. But what it also allows you is to see the shape of the face. So if you need it for security, that might be an interesting consideration. But my favorite feature actually is skeleton tracking. And the reason for it is because it's much more stable than face tracking. So just to demonstrate you, this is downstairs. I went into the reception and you can see that my skeleton has been tracked fairly quickly. And down below you can see that it's gaining and losing my face, but my skeleton seems to be at least trackable throughout the entire session. So how you can use this? Well, the moment you detect the skeleton, you also know where the face is. And then you can take a screenshot of the face, try to recognize it, and once you get the identity, you pin that identity to the skeleton. So when you lose the face, you no longer need to worry about who is that person when it pops back into existence for the face detection. You can just look, okay, this is the same person from that skeleton, and I already know who that skeleton is, so I don't need to recognize them again. And with that, I just want to show you how you can leverage infrared and depth camera with cognitive services. One interesting thing you will notice with infrared and depth frames is their 16-bit scale, grayscale frames. But the cognitive services only supports 8-bit. And the difference is like between 65,000 to 255 pixels, values per pixel. Now just imagine how can you convert such a massive number into such a small number. And this is why you need some pre-processing. In some cases, the APIs may do that for you, and they'll do a good enough job. But you know, what can happen is on the left, I have a really good software. It detected me, it recognized me really good. It showed all the details. You can even see some of my veins on the arm. It's that good. But on the right, it was a pretty poor software. And you can see it's not really that good of an image. And one of the filters, if you're really interested in that topic, you can look at filmic curve operator. But there are a lot of other filters that allows you to convert from 16-bit to 8-bit, or even use APIs that does that for you, so you don't have to worry about that. And one very important thing is just switching from color to infrared won't magically make the cognitive services work. Unfortunately, when you look the world from infrared perspective, the world is a little bit different, including our faces. So you may need to re-upload the images with the infrared camera. So that's a big consideration, especially if you have a massive number of people and you can get them in to take the image with the infrared. And the depth sensing camera, while currently most of the cameras are too unstable to use, because when they scan your face, it's almost like a sea. It has a lot of interference. There are already cameras with algorithms that allow you to smooth out to such a degree that you can just take a snapshot and it looks like a really beautiful face, and that can be used in cognitive services to recognize a person. And just to mention one, the Azure Kinect, I'm not sure how it's called, it's Azure Kinect something. They already have algorithms that can be incorporated into the hardware to smoothen out the depth sensing to a point where it looks almost perfect. And to recap the presentation, we use cognitive services because they're easy to use and they're scalable. If you do real-time facial recognition, there are some consideration. If you don't do real-time, you probably will be able to get away with the free tier. The camera quality is very important, as well as it's important in what environment you are. Just to give you an example, if we would use a webcam downstairs, we would have to write massive amount of code just to cater for all the environmental changes that happens. But instead, we used Kinect, which can handle different lighting situations pretty well. So we didn't need to write the code. We didn't need to change the environment in order to make that work. And everything is fine. And having spatial cameras is very, very useful. So downstairs for Sophie, what we are doing is when you come very close to the screen, we make a really good trick. If it recognizes your forehead and it no longer can see your face, we simply track your previous identity. We already know, okay, the person is too close to be tracked, and we use depth sensing to achieve that. And with that, I thank you for listening. You have all the URLs here, and thanks. Are there any questions?
Yep. How accurate is it?
Let's.
Oh, sorry. How accurate is it? I mean, does it correctly recognize everybody?
So it's fairly accurate, and the more images you add, the more accurate it becomes. Because we don't have too many people, we actually upload only one image for most of the employees, and so far the accuracy is pretty good, despite only having one image. Mm-hmm. Yeah, any other questions? Yeah, behind.
I'm pretty sure it was like the Apple phone or something that had that joking sort of, it was racist because it couldn't detect like the black people in the facial recognition thing. Like, does this have any sort of issues with, you know, not white Caucasians?
So Microsoft is really good at that. Not just they're trying to include as big sample as possible, they're also calling out to government to control them, not really control them, but to basically give some limitations on, or what is the minimum requirement for being a facial recognition service that can be used in government and other areas. So they're, I think, the only company currently in the world, the big company that pushes for that everyone else is looking into them and be critical about how that works.
You said the camera quality makes a big difference. Yes. Do you have any recommended cameras to use and any hardware features of those cameras that help in this instance? Like you've mentioned the Kinect, is there anything else?
So Intel RealSense is another camera family. Right now they have a D400 series, which I hope will soon get at SSW. And it's one of the first consumer available cameras that, at least based on the specs, can match with Kinect Vision 2. All the others were like half of the resolution or half of the speed, or didn't manage to get long enough distance. But this generation of Intel RealSense, I'm very, very eager to try them out.
What about using cameras that are on a phone or an iPad? I mean, they already do facial recognition.
Yeah, so what about using cameras on the phone or other devices? Yes, it can work. The only thing you have to be aware is if it's a cheap phone, you can have problems with quality of the image. But because usually those images are very up close and usually not taken at night, it shouldn't be a problem. Yes?
Just getting back to the question of accuracy, have you looked at, well, I guess, is it possible to configure yourself the confidence level to avoid potentially false positives? So obviously when you're talking about accuracy, you can be talking about false negatives or false positives. If you're using it in a security context, you might want to set a threshold where, you know, you might want to say the service would need to be 100% or 95% or greater certain or confident that that is the face it's detected. False negatives might not matter so much, but again, in security, it might be more important. Is that something that you can configure yourself?
We haven't used the Sophie for security reasons, but you do get back confidence. We haven't strictly tested how well can be used for security purposes. But as I said, you get the percentage, and in theory, the more images you upload, the better results. And which is why I found the depth sensing streams very interesting, is because now you might be able to take a color image and a depth sensing image and try to send them both and see if they both come back with the same person, rather than just relying on one single stream of images. Yeah. Any other questions? Yes, one question over there.
Is it just for faces, or can you use it? Can you train it to recognize objects as well?
That will be Vision API. Yeah, Face API is not necessarily a model like that you can just use in TensorFlow. It's a workflow of models. So based on how the face looks and things like that, it may go different routes, which is why they won't give you just a downloadable model for you to plug into TensorFlow. Yeah, any other questions? So have I played around with emotion detections?
Yes, you have. We saw it. It said you weren't happy on that walkthrough.
It says I was amused. We have played around, but you know, having emotion detection is really, really awesome. But you also have to understand the human nature. You can be a little bit grumpy from the outside, but happy from the inside, and the cognitive services will say you're grumpy. Or it could be the other way around. So yes, the emotion APIs is very interesting to play, but my personal opinion is take it with a little bit of salt, even if it's 100% accurate.
How does it deal with headwear?
How does it deal with headwear? So if you use glasses, it should be perfectly fine. Sunglasses don't work too well, and any kind of wear, as long as they don't cover your face, they'll be in a good shape. There are some cases where a haircut could cause a reduced accuracy, but usually it's not that much of a problem. Sorry?
Facial hair.
So what about facial hair? Usually it's not a problem, but if you suddenly grow a really large beard, same as with hair, it can get to a lower confidence, and in worst cases, it doesn't recognize.
Well, you said if you suddenly grow a beard, right? I mean,
Well, okay.
are you saying that it automatically updates images like with your 5 o'clock shadow and then, you know, like a bit of stubble and what have you? Like if you grow it gradually, you know, is it okay?
Because this, I have a medical condition, I had to grow a beard.
Yeah.
As I grew the beard, none of the facial recognition stuff had any problems at all. As soon as I shaved it off, because that's instant, it did. So the beard grew in over like a month, it was fine. But taking it off in a day, that stuck them all up.
Yeah, and
I've got a Surface Pro, and I've been using the Windows Hello facial recognition probably about 2 years or so. And I can have a haircut, grow my hair longer, shorter, facial hair, shave it, gain weight, put on, you know, lose weight, head wear, no problem. It recognises me every time. Pair of glasses, fail.
Glasses.
It's doing it's checking your skeletal structure around your eyes.
Yeah.
yeah, similar problem is with iPhones. They also checked mostly at this area, which is very practical for, you know, a device that you hold in your hand, so you don't have to look like that. But yeah, as soon as you get your sunglasses on, or sometimes even glasses, it's a problem. That's why full facial detection is usually better, because it looks at overall shape of the face rather than just one part of the face. Yeah, any other questions?
Have you compared it with the AWS equivalent?
So the question is if I have compared it with AWS.
Only because I have it working on AWS. And
so long story short, we were doing this like a year and a half ago. We tried out different cloud services, offline services, and there wasn't enough differences between those services to say, hey, we definitely should go with AWS solution or Face++. I'm not sure if Google had back then. I think Google had something, or the Cognitive Services, and we just said, well, there's not enough difference between them, and we are Microsoft shop, so we'll go Cognitive Services. Yeah, but the offline solutions, they are good until they become racist. So, yeah, if you want to avoid that, you might better off going on something like Azure Cognitive Services, because they're updated, and especially with Microsoft, they're trying to be regulated regarding these issues. Yeah, any other questions? Well, thanks for watching, and have a good night.